Good morning from Denver, Colorado, where I am. It's only 8:34 in the morning. I know it's 10:34 in New York time, about 8:04 in Pune or in India. But welcome to all of you. My name is Kishore, last name is Kulkarni, and I am the president of Society of Indian Academics in America, SIAA, which is a old society started way back in 1980s, and it has been very active society for academicians in USA. Before me, presidents was Dr. Ravindra Kulkarni. Before him, um, Vinod Vinod was there too, and Rishikesh Vinod, and these able people have carried the SIA very nicely. Um, I think what we have learned in a pandemic as a positive externality, economists would say, is an ability to hold these webinars per month. And if you know somebody who wants to present in these webinars, we welcome your suggestions for the future. But essentially, we do any academic issue that a speaker, and we do look for very good speakers, obviously. But that's what we have been doing for the last 3 years now. So this could be Dr. Thakur very easily 50th or 55th webinar you are offering. Many people have done a good job doing it. Well, besides the webinar, SIA is busy holding at least biannually conferences internationally. We did that one in Surat last December of 24. Now that's 23, December of 23, we did that. So December of 25, we will have it in Pune, and Sri Balaji University, Pune, SBUP, has already agreed to host it. There is a call for papers of that conference on our website and siaus.com. So you all are welcome to send your papers for presentations in that conference. And generally we invite all academic issues of Indian origin. So that's about SIA. And with that, let me pass it on to Dr. Ravindra Kulkarni, who has invited Dr. Dinesh Thakur to do the presentation for today. It is my first time opportunity to meet Dr. Thakur on computer at least. And so I will pass it on to Dr. Ravindra Kulkarni. He will spend about 40-45 minutes presenting. Then we'll have 15 to 20 minutes of questions and answers as usual. And here we go. Dr. Ravindra Kulkarni, floor is yours now.
Yeah, it's a pleasure for me to welcome Professor Dinesh Thakur, a young, very reputed number theorist who did his undergraduate from University of Bombay and then a PhD from Harvard. His advisor was John Tate, again a very famous number theorist. He won the Nobel Prize. Dinesh has spent many years at the Institute for Advanced Study, at TIFR, and many research institutes, and has worked with very distinguished people like Deline and others. He has taught at the University of Arizona, and then presently he is at the University of Rochester. He regularly comes to India and gives lectures about his own research and some interesting mathematics in India and elsewhere. And in particular, I have heard his many talks at Bhaskaracharya Pratishthan. He has also been an editor of several number theory journals. But he is really a polymath, and he can give interesting talks on many subjects. In fact, for a long time, I wanted to organize some webinar on mathematics and music. If you're a normal person, you like music, but mathematicians like to ask why you like music. And although the subject goes back to at least I think Plato and in our tradition Samaveda, it involves the physics of sound and vibrations and physiology of human ear. But there are certain mathematical principles underlying the rhythm that we experience, and that is where the mathematicians get interested in. And many mathematicians are interested in music. I remember a famous paper of Mark in 1966. Can you hear the shape of a drum? Can you hear the shape of a drum? So that was really a mathematical formulation of a certain question on Laplacian. But the answer is, you can hear many things about the shape, but not completely. Not completely get the whole drum. That is the kind of conclusion that the mathematicians got. So there are many theories, and I think Dinesh is going to explore, I do not know exactly, but some issues about explaining mathematics behind some Indian classical music. So I invite Dinesh.
Thanks very much. Thanks to SIA for inviting me to talk on this. And in particular, thanks to Professor Ravindra Kulkarni for suggesting the topic of music and maths. Both have been my passion for all my life. So that's a good topic. And I wrote something about 10 years ago, 10, 15 years ago, I wrote an expository article for Resonance, which is the science education journal of Indian Academy of Sciences. And I got a lot of feedback and a lot of discussions with many musicians and scientists on that. So I thought this is a good opportunity to give an update on that. So I'm very thankful to you. So let me start. As I said in the abstract, Indian classical music is a very developed art, but it's also, the commentaries have been written as a science. But since the words change their meaning and practices also change over the centuries, there is a lot of confusion in one particular area, which I want to focus today, and a lot of inconsistency in the literature even today. So I want to discuss my understanding of the underlying and very elementary mathematics, nothing like the shape of drum, which Professor Ravindra Kulkarni mentioned. So, I mean, there are lots of issues involved, but I'm going to talk about a very simple model. So first, let me repeat the warning which I gave in that paper when I said that I am neither a trained professional, neither a trained performing musician, nor a historian of the development of music, and not a scientist who has done these experiments himself. So you have to take everything what I say with caution, and things might be wrong, okay? But I am explaining my understanding of the elementary mathematics. So Indian classical music, by that I mean Raga Sangeet. I think all of you know what Raga Sangeet means. So the melodic aspects are what we call ragas, and rhythmic aspects are called tals, and both depend on what is called samvad, or dialogues or interconnection between parts. So I don't think I have to say much more. Raga is much more than a scale. It allows, it's a very highly structured thing. And then you have infinite freedom in that rigid framework. So our Indian classical music is individual rather than several, like it's not sung in chorus, it's not pre-composed. It explores the artistic freedom in a very rigid framework. Now, as Professor Kulkarni mentioned, there have been lots of writings, for example, classification of ragas, classification of talas, enumeration of patterns. So for example, when you have tans, that means fast movements, they have in Indian system, systematic enumeration, counting, and production of permutations. So it's just a enumeration of permutation is mentioned. And this was way before anything like this was done anywhere else. So this is mentioned, for example, by Donald Knuth in his computer programming books and so on. But that is all well understood. So Indian style was to give, not to explain why, but actually explain how things work. That was the Indian style. So many times they just made a sutras, let the students memorize the sutras and learn through that without too much explanation. And that created a problem. So this talas, enumeration of patterns and so on, there is absolutely no controversy. Everything is understood. One particular thing where things went completely wrong is what I'm going to focus on. And that is about musical notes. What should be the good musical notes as used in Indian music? So that's called shrutis. So, and we had, so this is well known. So you hear that there are 22 shrutis. Okay, so that's what I'm going to focus on today. So shrutis are a precise framework for Raga Sangit musical notes. So in the Raga Sangit, there is somehow 22 shrutis. And many people know pentatonic scales of 5, 7 surs or 12 surs. But that's, and 22 shrutis confuses people. So that's what I want to explain. This is very old thing. So I wrote only 3 dates, rough dates. So music and mathematics relation sometimes is credited to Pythagoras, which was about 5 centuries before Christ. And basically what he understood is, if you have a string, simple ratios of where you pluck kind of thing correspond to the musical notes. So I will give an example. So he talked about harmonic series, harmony, all those words come from this. And he built a big philosophy by saying that God created integers and integers corresponds to music. And then there were, this philosophy was even talked, people like Kepler or Copernicus, I don't remember, but they talked about music of spheres. Even the planets' distances and so on are in simple ratios. So God created music. That was sort of the philosophy at the Pythagoras. And he noticed, I will say exactly, then the second date I want to say focus is about, again, there is a dispute, 100 BC to 100 AD, first century before or after Didymus. And he adjusted some of the Pythagoras thing. And probably Indians also did it. I didn't know the reference. What we call Swayambhu Gandhar. So I will explain that. What we call a Swayambhu Gandhar in Indian classical music is done by Didymus around that time. And this 22 Shruti model, the main text where this occurs is by Bharat and again, there is a dispute about the date. It might be 2 centuries before Christ to 3 centuries after Christ. That's sort of the span which is given on the books on him.
Or maybe he lived 500 years.
Say that again?
Or maybe he lived 500 years.
So that's the, yeah, no, I'm certainly saying that there is in that range somewhere is the current guess. Anyway, what I'm going to do is I'm going to talk about how you derive this plan. Then I will discuss some of the aspects, which samvads are there, what are the compromises in this model, some duality aspects. Then I will explain why there is a controversy. Then I will compare with Western music. And then I will compare with theory and practice, and I will suggest some experiments. That's the plan of the talk today. And feel free to...
I would add that Bharat Muni would take it back to Samaveda.
Yeah, as I said, I'm not historian and I just don't care too much. I just wanted to give you some dates to see how things were, right? So let's move on. So what are the 5/7 systems? So in Indian music, compared to Western music, you usually have a fixed tonic. That's called Shadja. And Shadja means it gives birth to 6 things. So 1 plus 6 is 7. That's how sort of in the name itself, it says 7 note system. But anyway, so the main point is the frequencies are pursued with the ratios. So if you consider Sa is as a frequency 1, so you should just normalize, then the higher octave Sa will get ratio 2, right? So if you suppose Sa is 240 hertz, then the higher Sa will be 480 hertz, okay? So that's what I'm saying. So, and they sound like unison. They sounds like the same note in the next octave. So basically frequency F and F times 2 to the N are identified. So that's called an octave. So in Western music, they call it octave because it's the 8th note, which is the same note. We call it saptak for 7 notes because there are 7 notes and 8th one is the same. So octave or saptak is basically the same. And F times 2 to the N frequencies are identified. Now, usually when you just say frequency, you are thinking of in mathematics sine or cosine or some periodic function with exactly like that. The musical notes are complex. They are like more like a Fourier series. They are periodic, but several multiples of this sequence frequencies occur in the musical notes. So with F, it will be 2F, 3F, 4F. That's called a harmonic series. That is called partials. They occur in the complex musical tone, and ear perceives frequency F from this Fourier series. Now, the notes are consonant. For example, 3/2 frequency. So 1 and 3/2, that's what exactly, that was the Pythagoras discovery, that 3/2 sounds pleasing, just like 2 sounds pleasing. Double the frequency, it sounds, and if you use both at the same time, they give you pleasure to your ears. Same thing happens for 3/2 or for 4/3. That was 3/2 is what is called pancham in the music. And why is it sound consonant? So basic theory is that there are these partials, and if it's 3/2, simple ratios means some of the partials will agree, and maybe neurons fire simultaneously, and you get a pleasure out of it. Okay, that's, I mean, I am not going to go into neurology or perception of ear and so on, but let's just assume that simple ratios like 3/2 give you consonant frequencies. So 1 and 3/2 sound good together. So if you go 1 times 3/2, you go higher, you can go down by 2/3, and then you bring it to the same octave, it becomes 4/3. That is called madhyam. Okay. And you can do 3/2 of 3/2. That means you can consider pancham as a sa, and you can transpose pancham of a pancham. That means fifth note of a fifth note is called re. That's 3/2 square, which is 9/8. And you can do 3/8 cube, 3/2 to the 4, and so on. And I just wrote down, those are the dhaivat and gandhar in usual thing. And this was what Pythagoras was doing. Pythagoras realized that these things are giving good ratios of musical notes. And the Didymus, which I mentioned after Pythagoras, he realized that this 81 or 64 is getting too complex already. And it might be better to do 80 over 64. Okay, that's slight, that is called just tuning, and that is what is called Swayambhu Gandhar, and that occurs at 5/4. And as you can see, the simple ratio, 5/4, lower complexity ratio, it does sound good to our ears. So Tanpura is supposed to give you this 5/4 rather than 81 over 64. So 3/2 is nice, but there is some adjustment actually makes it better. So there are a few ways of saying why 5/4 is good, Swayambhu Gandhar. So in Tanpura, the way Tanpuras are made, the fifth partial is very strongly heard. And that's why 5/4 you can actually hear from Tanpura, which is actually you are just plucking sa twice, lower octave sa once, and pancham once. So it comes from either from the higher partials, or also it comes from interference. So there are trigonometrical identities. I forgot to say that there is. So what is not consonant is called dissonant. That sounds bad to your ears. Okay. So, and if you play two notes which are very close to each other, then there is a phenomena called beats. That means very unpleasant, like a modulation of sound happens. And this happens because of trigonometric identities. If you take cosine sine x plus sine y, everybody knows there are formulas for those things in terms of sine of x plus y or x plus minus y and so on. And these beats allow you to, I mean, because beats shows that their frequencies are slightly off, and that allows you, the tuner, to actually correct the frequencies. But what I'm saying is, so if you have 1 and 3/2, its average is 5/4. And that's how 5/4 also comes from trigonometric identity. So there are various reasons, and I'm not going to go into the reasons right now, why 5/4 is better than 81 or 64. Okay, so this was understood and mentioned by this is called a Didymus comma in the Western music. And anyway, similarly, you can, instead of dhaivat, which was 27/16, it becomes 5/3. That's much better. And earlier there were 5-note systems, which I wrote as Saremapa Dhasa or Saregapa Dhasa. And those people who have learned Indian music will know that is a Durga Rag or a Bhoop Rag. Those are the notes or scales of those things. So there were some 5-note systems, and only 5 notes were used. But then they're also used, so if you just continue with this process by again multiply by 3 by 2 or 9 by 8, then you also get the ni and n, which is the 7 notes. And this is a 7 note system which is used. Now you might say, why only 7 notes? Why you can't just continue this thing forever, right? So let me explain what is the usual explanation. So first of all, 3 by 2, power of 3 by 2 will never be power of 2, right? So this Pythagoras process, Pythagoras iteration, let's call it, it will never end. So that will give you infinitely many things. So you have to compromise something. And one compromise is there are 12 notes, because 3 by 2 to the 12 is very close to 2 by 7. 2 to the 2 raised to 7. So 12th note is basically sa again. Is that clear? That's what I mentioned. And this can be seen by continued fraction. If you know little mathematics, you can use continued fractions to sort of justify that, why 12 is good. But anyway, why 7 is good? So instead of multiplication, let's use logarithm to make it addition, because everybody understands addition better and it's sort of more visual. So you scale multiplicative ratio of 2 to log, so it will be log 2, and you make it multiply by 1200. So if you make the whole octave, so sa to upper octave sa to 1200, then the frequency corresponds to 1200 log to f. And if you just find out, you just take out your calculator and find out what these things translate to, 3 by 2, those ratios which I mentioned in the logarithmic scale, Shadja Pancham, which was 3 by 2, is almost 700, it's 702 point something, okay? And then if I look at Sa and Re, that's like consider the next one, that is almost 200. So what that means, so that people thought of 200 as an approximation of a tone and 100 as a semitone. And so Sa Re Ga Ma Pa Dha Ni Sa, that means 200, 200, 100, 200, 200, 200, 100, like that. So you get 1200 out of 7 notes, which come up naturally. First is Sa, Pa. If you go down, you get Ma. Those are the simplest and best sounding chords. Now, Indian music is different because we don't use chords that much. Everything is built in terms of relations to the Tanpura, but the principle is the same. You get 700 is natural and 200 is natural. So if you just build up with the tones and semitones, you get 7 notes. And that's called Sa Re Ga Ma Pa Dha Ni Sa. Now, typically, you would like to be symmetric. So if there are some semitones, why not use everything semitones? If you do that, exactly, you get 12 notes. And that is not bad because of this fact I mentioned. So 3 by 2 to the 12 is almost 2 to the 7. And the difference in a sense of a ratio is called Pythagorean comma. So Pythagoras himself probably realized this. So there is this slight, it's a very small, it's very close to 1, but that's called Pythagoras comma. And this 81 over 80, which is this adjustment of Gandhar to the Swayambhu Gandhar. So Pythagorean Gandhar to Swayambhu Gandhar, the adjustment is called comma, that's 81 over 80. And this is called Pythagorean comma. And this 22 system, so people did lots of adjustments for that. And so once more, there is a simplest systems of music have 5 notes. 7 notes are most common. And then 12 notes is what we use these days mostly. So like if you look at some harmonium or any keyboard, it has 12 notes in 1 octave. Okay. And this is the reason we call it Saptak, because there were 7 notes. And the way you think of 12 is that, I'll say this later, but the Pancham is the 5th note in the 7 thing, and Madhyam is the middle note. That's why it's called Madhyam, right? So instead of in the 7 system thing, so the names come, Saptak, Shadja, Pancham, Madhyam come from 7 notes. Now we use 12 notes by using all semitones, which are roughly 12 equidistant notes, but this is roughly, not exactly. And this rough, if you make it exactly, that's called a tempered scale. And to ear, it doesn't sound that well. But it is used as a compromise. Okay, so the next thing I want to say is what is a Shruti system? It's a much better model because these 12 things, if you just use that, that's not enough. And if you use it equidistant, it doesn't sound good. So what sounds good has to do with this consonance and dissonance. So the Bharat, at least, I mean, I don't know who conceived it, but Bharat Natya Shastra has this complete description of what happens, and there are no numbers. He just explains, as I said, Indians focused on how rather than why. So there is no explanation. He just gives you a practical algorithm or model of what to do. But I am translating it into numbers, and I will explain why this works. And then I will tell you later why there was a controversy. Okay. So in Indian music, the shadja or sa and pa are sort of considered fixed or immovable. This is different in, say, Western music. So that's why we use your tanpura. We fix our shadja and pancham for a whole time, right? And they are constantly in a drone, and everything is in relation to that. So we need consonance with this shadja and pancham. That is the requirement of Indian classical music. Now, where do these 12 notes come up? The shadja and pancham are the two which I mentioned. The two things are fixed, and the other 5 things have 2 versions each. So their small r would be Komal Rishabh and Shuddha Rishabh. So the R2 version is called Shuddha, and R1 version, the lower version, is called Komal. And how do you get 22? Again, Shadja and Pancham are fixed, but each Komal and Rishabh version itself gets lower and higher version. And there is a big difference between this, how I went from 7 to 12 and 7 to 22. And that created a confusion because people thought that just like 12 are equidistant, 22 are equidistant. They are not at all. Okay, and so I will explain it slowly. Now, I should say that we get, in the North Indian classical music, we have unique names for each of these musical notes, which is called, so Shadja, then Komal Rishabh, Shuddha Rishabh, Komal Gandhar, Shuddha Gandhar, Shuddha Madhyam, Tivra Madhyam, Pancham, Komal Dhaivat, Shuddha Dhaivat, Komal Nishad, Shuddha Nishad, and then whole thing. Those are the 12 notes, 12 names. In South Indian or Western music, there are not unique names. Sometimes you say some note, then you say sharp version and a flat version, and you can have some kind of there is the double name, and that is not completely redundant because when they actually play something, they artistically use it. So they gives you some dissonance or how to approach the note and so on. But anyway, I'm talking about North Indian music. There is unique name. And the mathematics fits because of this identity which I wrote down, 81 to the 80. If you just multiply out these numbers. So these are called Shruti intervals, 81 over 80, 256 over 243, 25 or 24. Those are the intervals between the versions used. And as you can see, these are not equal. Okay. And so what I'm going to do, so I'm saying that Pythagorean cycle never ends. So because it's 3 by 2 to the power is never 2 to the 5. So the way you make Shrutis, so I'm explaining my explanation. As I said, Bharat didn't give an explanation. I'm just going to give its chart, and then I will see how to fit it. So the explanation is you go by up 3 by 2 6 times and go down 5 times, and you get the 12 surs, and then adjust by this comma 81, 80 to get 22 Shrutis. So for each of 10, you use these 2 things to go up and down. Okay. Next page, we'll have the chart. So you will exactly see the numbers. And so basically you are saying that you are trying to keep all the samvads, all the consonances which occur, you want to keep them as much as possible. Okay. That's the whole purpose of this, doing this. So if you want to keep a consonance, then you want to keep the 3 by 2s also, and you want to keep the 5 by 4 also. And you cannot do it infinite often, so you approximate somewhere. So the final answer you get, and I actually describe how you do that. So when you go up, then you use 81 over 80 to go down. And if you go down, you use the 81 over 80 adjustment to go up. So let me show you by... This is the final chart you get. So let me just focus on this part right now. Okay. So this is the table of frequency ratios that you get. So I am called size 1. The ray would be whatever the size, that multiplied by 256 over 243 would be the frequency of ray, and so on. So this is the frequency ratio table. This is supposed to be the exact answers. And then we'll talk about theory and practice and everything later. But this is the frequency ratio. So you can see 3/2 occurs at Pancham. P, what I call P, that's 3/2. 3/2 times 3/2 is 9/8. That is R22. Okay. 9/8 times 3/2 is 27/16. That is D22. Okay. So you are going up and down. And if you are seeing this for the first time, it might be complicated. So as I said, I'm going to give you a reference where all the details, and you can you have to look at this and actually work out the numbers and so on. But the principle is the same. Basically, you use the 3/2s going up and down in a constrained way, because you cannot do it all the time. And that Pythagorean comma tells you how much to do it. And then you use by 81/80 adjustment, which comes from Swayambhu Gandhar versus Pythagorean Gandhar adjustment. And doing that, you get two versions of each of the 10 notes, and Sa and Pancham, Shadja and Pancham are Achal. Okay. Now, usually if ratios are hard to pursue and you are like equidistant things. So as I said, 1200 is if I use the logarithm and multiply by, adjust the scale to 1200, then this is called cents, and these are approximation. The first table is supposed to be the exact table. Second table is supposed to be the approximate in cents. So the Pancham is, as I said, 702. That's like 7 semitones from Shadja. Rishabh is 90. So there are two versions. One is 90, one is 112. So equal tempered would be 100, right? So 100, if you do equal tempered, now pianos in Western music are supposed to be almost equal tempered. So they are like up by 100. And that's why for a trained Indian classical musician, piano doesn't sound that good. And they don't use that. They use different tuning, because 100 is different from 90 and 112. But even then, 702 and 700 are not that off, and ears do not still, even a very trained professional musician will see the difference between 702 and 700, but most people don't pursue this difference. Okay. So anyway, this is the compromise you get. This is the table you get. This is called a 22 frequency Shruti table. Okay. So once more, there are only 12 surs, but 10 of them have two versions of each, slightly lower and slightly upper. And that gives you 20, plus Shadja and Pancham gives you 22. That's the math. And these are the ratios. And I explained the principle. I explained how to get it exactly, and more details I can sort of refer to some paper. So now, how did Bharat explain this? That also I will say it in words. Again, I will refer to the paper for more details. So Bharat basically give an algorithm. He said, take two veenas. Veenas is some instrument like sitar, basically, and you use some natural scale on one. And then he said how to retune the other veena. That's called Chatussarana, or change 4 transpositions or 4 changes of scales in 4 steps. Each step gives you the differences between the Shrutis. So the Shrutis are established by the way Bharat explained, but he never explained what does words like natural scale, Shruti, what does Shruti mean? What does natural scale mean? He didn't mention that S and P are not supposed to move. And that creates a lot of confusion. So he was there like 2000 years ago, right? So when people started writing books in say 1800 and 1900s or commentaries on these things, they gave completely wrong kind of tables. So even Bhatkhande, which is the standard text for Indian classical music, has lots of tables. Some of the tables, they thought it's a 22 Shruti. So he gave a table which is 22 equal parts of octave. But he just sort of said it as a theory. So if you use that, it sounds horrible. So it was just not the correct thing to do. So there are lots of mistakes because of that. Some people use the natural scale, which I mentioned, Saregama Padanisa, which is usually Bilawal That scale. For here, actually, he meant in those days, it was a Kafi, or which is called in Western music, it's called Dorian scale was used. And that uses the ratios 1, 9/8, which I already mentioned, which is 3/2 square. 5/4, Swayambhu Gandhar, and 4/3, that's the Madhyam. And then Sa to Ma goes to Pa to Sa by just multiplication by 3/2. That's called what is the current natural. But in Bharat times, probably natural was shifted by 3 by 2. So when the name, maybe the names changed or something changed. And so his natural was 110 by 9. This is a different version of the same Rishabh. So Rishabh has two versions. One is 10 by 9 and 9 by 8. And as you can see, the difference is 81 over 80, which is the intershruti interval, which is called a didymus comma. And similarly, so if you shift 1 to 9 by 8, that's the transposition gives you this scale. And that is called Kafi scale or Dorian scale. And if so in Bharat experiment, you have to, on the Achal Vina, you have to use this scale and then do what it says and everything fits. Okay. So I explained that not here, but in my paper that everything fits, and this is nothing new. So I will give the references. So I'm not saying I gave sort of different explanation, but this is well understood. But also there are lots of wrong tables all over the literature by very good people also. And the reason was because he was using words and not any mathematics, and words change meaning, practices change meaning. And so there was a lot of confusion. So for example, he mentioned that there are 22 Shrutis. So people thought equal 22 Shrutis. People thought Shruti was a unit. It's not a unit. There are 3 differences of Shrutis intervals. So Bharat talked about 3 Shruti intervals and 4 Shruti intervals. And again, there was a confusion. People thought that 3 equal parts or 4 equal parts, but he was not talking about that. It was, so the language was not explained. And that's the reason why things were problem. Also, some people started with, when you say Shruti of a Shadja, are you going down or are you going up? So some people start at Nishad to Shadja or Shadja to Rishabh. So there was a confusion on multiple fronts. And there are literally several tables, and I will talk about this little later also, which are giving totally different understanding than this. And many of them, when you try it actually out, it doesn't follow the principle. So many tables don't follow the principle of consonance dissonance. So they are not good to the ear. And when this was given, there was no technology to produce this thing. So it was not really checked. They just theorized something and it was wrong. Anyway, so 22 equal temperament is a wrong scale equations. And people didn't think about Shadja and Pancham Achal. So if that is true, there should be 24 Shrutis, right? Because 12 surs each get 2 versions. So that will be 24. So there was a confusion why there were 22. The point is, if you have Shadja and Pancha Achal, if you change it by 81 over 80, Shadja and Pancham is constant in the drone. There will be a lot of dissonance. So Bharat and ancient Indians cleverly avoided the dissonance because Shadja and Pancham is constantly reinforced. So you don't want to have Shrutis for them. For every other note, you can have Shrutis. Okay, that was the idea of this 22 Shruti model. So there were, as I said, there are many inconsistencies and wrong mathematical claims occur even now. So there are actually 3 books written by Vidyadhar Oak on this in 2007 and so on. And he mentions this table. He doesn't give, so I will give references to the earlier table. He doesn't give the references, but he makes a lot of mathematical mistakes, commenting that some samvads exist, some consonances exist in this model where they don't. And I want to talk about what exactly exists and what exactly is claimed wrong. So I gave you this 22.
Did you explain this periodicity of 8, that why 7 or 8?
Yes, I did, right? 2 to the, so now the 7 comes from, as I said, Pancham, right? The 12 thing comes from very naturally by the Pythagorean commas. 7 comes because first you get Pancham, and it's just how the music evolved, right? First you get Pancham Madhyam, and in the 1200 scale, it gives you 200 and 100. So what is the easiest way to fill this up? 100, 100, 100, 100, and that gives you 7. Okay. So explanation for 7 is that. Explanation for 12 is you do all hundreds. And this is very completely different idea. This is making samvads, right? So 7 and 12 ideas are different. Here also there are 12 notes. So people don't call these 22 notes. They call it 12 notes. And 10 of them have 2 slightly differing versions. If you use all these versions, you get a system which is used for raga. A given raga, usually you won't. So for example, look at R11 and R22 and say any of these two versions. So R2 has two versions, R21 and R22. These are the versions of Shuddha Re. In a typical raga, they won't be used in the same raga. Different ragas, depending on which consonancies are used. Raga is a scale which has certain limitations on how you go from one sur to another sur. That has to be consonant. So whether particular raga will use this shruti or that shruti, that will be different. So you don't use 22 at the same time. It's supposed to work for most of the ragas, but each raga will usually use 12 or fewer notes and only 12 or fewer shrutis, not more. Okay, there are exceptions, and which I will come to that later, but this is the system. So this is like a robust model, all-purpose robust model, which is supposed to be good for most of the ragas for the Indian classical music. That's the idea. Okay, so now, as I said, there is a controversy, and the controversy is existed for a long time, and people now sort of understand what things are better. So there are simpler subsystems, which to answer your question, I want to show you the simpler subsystems, which also people know for long term. Like if you take size 440 hertz, these are, I have selected out of 22, I have selected 7, and then I have selected below 12. So I am giving simpler subsystem. What would be the simpler subsystem? 240 is 270, 300, 320. So these are the sort of easy frequencies. And 240 was made in such a way that, you adjusted lots of 2s and 3s. So when you take ratio, you get integers, but it's totally artificial. Similarly, so Shuddha Suras here, so I have said how many samvads you have there. So I will skip this part. And so I have given you so this system, there are some simpler subsystem of 7 notes or 12 notes. And there are, so 22 shrutis is just one model, okay? 7 notes, there are 2-3 versions, because depending on, so for example, as I said here, you can use Dhaivat to 400 or 405, depending on what principle you are using. And both systems have, so you can use different selection of shrutis to get good subsystems. So 7 and 12, there are different systems, and different systems of 7 and 12 are used depending on the raga. And again, I have some examples in the paper, and Vidyadhar Oak has done a very nice job by looking at lots of ragas and giving you different which shrutis are used, should be used in which raga, right? Which version should be used in which raga and why, because of the consonance principle. So that consists of a theory of this thing. So in all this Tivra Madhyam or Vikrut Madhyam, which is in this table, is, you can see M22. M22, it looks like a most complex ratio here, 729 or 512. This is too precise, it's just too complex. And that's where all the complexities or all the incompatibilities are dumped in this model. So this model does include some compromise. It's just not a perfect model. The compromises are all dumped at M22. Okay, M22 is, so as I said, the Madhyam, which is 4/3, which is a nice Madhyam for 7 note system. But if you use the 22 system, then M22 is supposed to be the positionally the middle of it. And it's a compromise. Natural requirements of consonances are mostly met. They are not met at this point, and that's called M22. This is the beauty of this model, that instead of infinitely many, you just use 22, which work all the time, but there is a complication near M22. And the Madhyam Samvads are lacking. And so, as I said, this Oak book is very, very nice. It explains lots of ragas and so on, but it has mistakes. It says that they are there. So he wrote 3 books, and all 3 books, which are in 2010, 2015, around that time, they still have these mistakes that there are some samvads there, which is not the case. So there is some adjustment being done there. He called it, that's the problem. He called it Shruti Gita, and it comes from the God. And then if you start saying things come from the God, then everything has to be perfect. And as Pythagoras pointed out, it's not. And then you don't, so then you just, rather than blaming yourself or blaming God, you just claim wrong things. That's what happens quite often. So that's what happens here. Anyway, so Kumar Gandharva, I will say he used to call this M22. He used to, I mean, our musicians who were great musicians instinctively understood that. So Kumar Gandharva, I have recordings where he says this Tivra Madhyam or Vikrut Madhyam. They called it Vikrut or Tivra. They called it he's a Mahabadmash. Or he called it that space no man's land. So that means, it doesn't really belong to the theory, but it's somehow no man's land. So there were this kind of nice figurative things used to describe these compromises. The difference between Western and Indian thing is, it's in, so here in Western music also they realized that, and they called it devil's interval or diabolus in musica. That was the term. So in all music, it was understood that in the middle there is some problem with the ears, you don't perceive it too well. And the Western approach was just ban it. So there are several centuries, this note was just not used. So out of 12 notes, sometimes you don't use this interval. In India, took completely different approach. They said, exploit this artistically. There is something wrong, so you have more freedom, just exploit it artistically. So there are lots of ragas which use the Tivra Madhyam very beautifully. So anyway, it's just so now I want to say something here. Pythagoras, as I said, had a whole philosophy of natural integers coming from God and corresponding to music and mathematics. And he had a Pythagoras theorem, right angle triangle. And he realized the simplest triangle with sides 1, 1 has other sides square root of 2, which is not a ratio of rational numbers. So as the story goes, as the myth goes, he really felt bad about this, right? That square root of 2 is like cheating. Now, if you think of 2, the middle will be at square root of 2. So from the music and also from the geometry, he couldn't escape square root of 2. That's what I want to say. So he sort of the Pythagorean school was very unhappy about square root of 2, but it came naturally with the Pythagoras theorem itself. And it also came with the Pythagoras theorem music, where square root of 2 is middle. And you approximate with this M22, and it still sounds, it's like a compromise. So they had this philosophy, and Kepler had this philosophy of music of spheres, about astronomy and planets, how they move. And actually, I wouldn't blame this, because this is a philosophy which motivated them. They were religious people. They motivated them to study astronomy well. And Kepler made lots of good discoveries starting from a wrong thing to prove. So that has also, they started with God, but ended. I'm just kidding. They ended up with the devil's interval. Just kidding. This is just a joke, but that's what I wanted to say about square root of 2. Now, in this, there are some structures. One structure is Shadja to natural madhyam. This M11, which is the 4/3, is a natural madhyam. If I multiply by 2, it goes to Pancham to Shadja. So Shadja to first madhyam goes to Pancham to Shadja. That is used a lot in the Indian classical music. But there are 2-3 versions of madhyams which are missing in this. Similarly, going up and down is a duality between frequency F and 2/F. For example, if you go up by 3/2, you get Pancham. If you go down, you get natural Madhyam. That's the duality. And I want to, so after my article, Professor Govind Deshpande, who is actually father of Ashwini Bide Deshpande, he's a physics professor. He was a sitar player. He's a sitar player. And also his wife, Manik Bide, was disciple of Kishore Amonkar. So he has a lot of musical training. He told me some interesting thing. Then he said that with this duality, Shuddha Swaras, that means these 7-note things which I mentioned, as are called Shuddha Swaras. Actually, Shuddha and supposed to be opposite, is supposed to be impure, right? There is a typo there, but impure. The Komal Swaras and Shuddha Swaras are in duality. Except for unnatural Madhyam Shrutis, there are some duals, and Shuddha duals are Komal. And he says it's like a duality between Shuddha and Ashuddha, sharp and soft, Nara and Nari. And then he had a cultural Ardhanari Nateshwar cultural image in musical context. So he had some nice take on this duality, which I wanted to mention. Now, what happens with other Madhyamas? So, okay, so There are other, so instead of this very complicated 729 over 512 M22, there are some other candidates which people have used, like there is 64 40 over 45 is a substitute for M22. He didn't give any explanation, but it's the probably, oh, there is another typo here. Probably lowest complexity approximations with 2, 3, and 5 are the only primes occurring in the factorizations. So as I said, 3 by 2 has 3 and 2. Swayambhu Gandhar gives you 5. And if you just use those primes and multiplicativity, you get the simplest complexity near M22 is that. And it's also dual of M21. So if you use this duality to Madhyams also, you get this note rather than M22. So this is another thing I wanted to point out. Now, I just take a liberty of, I will talk about practice. So I talked about theory. I'm done with the theory. I will talk about practice and just 2 more slides and experiments. But before that, there are many Marathi speaking people here, and Professor Ravindra Kulkarni just mentioned Pula Deshpande. So I just wanted to share. Can you see this?
Yes.
So this is from 1974. Bhai Kaka is a Pula Deshpande. That's my uncle. And he sent me this thing about this University Music Center publication. It says, Dinesh la ha अंक पाठवणे. Dinesh, यातील संगीत आणि विज्ञान हा लेख तुला आवडेल. This was the start of my interest in connecting music and science. Music and maths or science. And this explains the Swayambhu Gandhar and Tanpura connection. So I just wanted to show you that. So this was in 1974. That's when I sort of worked out. I got interested, and then I tried to understand what Shrutis are and figured out this table. And then I realized that table was already known, except there were other tables also mixed up. So I'll say something about that in a minute. And I now want to talk about the practice. And you might say, okay, what do you, so because of Pula Deshpande, who was well connected with all the top musicians, I was also very fortunate to look at, I got exposure to these great musicians. So this is Mallikarjun Mansoor, that's Pula Deshpande on the left, and that's me on the right. So I wanted to show you, so I could at least hear, this is from 1975 or 74, something like that. I wanted to show a couple of pictures and then go to the practice. There is another picture here. This is again Mallikarjun Mansoor. This is Vasantrao Deshpande. That's me in the middle, around 70s picture and so on. And so I got to listen to many great musicians like, like Kumar Gandharva. Okay, so where did my slide go? Okay.
Kishori
Amonkar and so on. So I want to talk about a practice. And first I want to start with the quote, which I just recently learned. The quote is that in theory, the theory and practice are the same. In practice, they are not. Nice quote. So all this was the theory. What is actual practice as done by Indian classical musicians? So I talked with lots of musicians like Kishori Amonkar, Mansoor, Kumar Gandharva, because Kishori Amonkar gave lecture demonstrations on Shrutis. Kumar Gandharva actually is, in his writing, he also is very precisely. So I have heard from him, and also he has written things. So I'm going to say something about that. And Mansoor also, I have talked with him. And so I will quote them. Of course, you should not, it was my understanding in those days. So you should not hold them responsible for anything I say, except when I say something is written by them already, then it will be sort of more authentic. Anyway, in practice, there are lots of issues. When I say frequency itself, a frequency perception is a complicated issue, as you said. There is a biology of the ear, neurological interpretation involved, perception of a frequency from a complex tone. It's not a pure science wave. There are lots of partials. Sometimes the partials are missing, and there are cultural conditioning. These things make all the systems complicated. One thing I want to say is, there is almost unanimous agreement between all the musicians I talked about the positional nature of 22 Shrutis. What does that mean? They do think that Shadja and Pancha is Achal, and each one has a lower or higher version. Now, whether that version is the same as the table or not, it's not clear. Whether that version, that that is an interval or actually position. The endpoints are fixed, or you can go in the interval somewhere and that will still sound good. That is not clear. So in the practice, that is not clear. And what makes it complicated is we have things like mid. We go almost like a continuous feeling from one swar to another. We came oscillating, andolit swaras. We don't use chords. We don't sustain notes. Sometimes we just touch a note. All these things change the requirements about consonance and dissonance. So there are lots of complications in practice. And the Tanpura, everybody agrees that there is a Swayambhu Gandhar, and that is agreed. So let me just say, Mallikarjun Mansur used to say, I asked him this question, and he thought that, there are even more than 22 Shrutis. He thought there are different ragas have different, even more subtle than 22. He just said 22 is a compromise. There are more. Kishori Amonkar actually believed in the theory, and she said it's 22, and she used to demonstrate some of them. But I mean, I am not saying that she committed to this, but in a lecture demonstration, she quoted Bharata and started saying that this is the correct thing, and 22. Kumar Gandharva again believed basic 22 model, but many times he actually has written in his book on Anuparaga Vilas, where he mentions some other Shrutis in this particular raga. So I will say that. And now what happens to the keyboard? Keyboard is always a compromise. That's why in Western music also, the keyboard is not considered as the ultimatum. That is considered as a compromise, because you just get 12 notes. You cannot get all things. Nowadays, things are improving because now electronically you can make more. So there is something about how you make this compromise. Equal temper compromise is just never done in Indian music. That's only done in Western music, because Western music doesn't have a fixed sa. Fixed tonic or fixed shadja is not there. It keeps on changing. So they sometimes use piano. Indian piano is not tuned to equal tempered. They will tune it to what is called a Gandhar tuning. They will try to maximize the shadja Gandhar, shadja Madhyam, shadja Pancham Samvads, and for a fixed sa. Like you own a harmonium, that you are singing in a particular tone, that's your sa, and you maximize the tuning to get as many samvads as possible. This is the very practical thing to do. Srujan Deshpande explained me how to do that, and I checked that it's really maximizing for the compromises here. So things can be instrumental compromises. Now the modern technology allows you to do several things at once. You can just change by just changing something software, right? So you can use 22 Shrutis very easily, and just as you are playing raga, you can just adjust which Shrutis you want to use when you play the 12 notes. So that is a possibility. Achrekar, we wrote a book on Shruti. He used 36, 3 for each note. So he was not considering fixed Gandhar. So that contained the 22, but some people thought they should enlarge these things. So 22 is a good model, which is positionally accepted by most musicians, but it is not like, it's the end of the world. It's not like that. There are compromises people look at. So I end this thing by just, this is my, I have one more slide. So TIFR, 30 years ago, Bhave and Pandya, and they did some using the technology. Then they'll try to analyze Tanpura recording and see which harmonics come up. And 7, 11, 13 are weak, and that is exactly agrees with the consonance principles which you have used. You can see the ratios do not have these primes. They have only 2, 3, 5. And that's why the Tanpura is a good instrument, because it doesn't have those things. They are weak. So Tanpura sounds good and Surel to Indian ear. And Surel Awaz might also mean the same thing. So you should do the experiments. So I'm saying that we should do the experiments with the modern technology now. What are the harmonics in a good Tanpura? There are, Kumar Gandharva made good Tanpura recordings. What are the Surel people like, Bhimsen Joshi, Lata Mangeshkar, Rafi, Kumar Gandharva, Kishore Amonkar, Mansoor? You have good recordings of them, and you have modern technology to analyze the harmonic distribution, and that should be done and recorded. Now, Kumar Gandharva wrote 2 volumes of his compositions, Anupraga Vilas 1 and 2, and he mentions several positional things. I will mention 3 ragas which he mentions. Lagan Gandhar is his creation, and he says that both the Komal Gandhar Shrutis are used in this raga. So that's a concrete statement from the master of musician that should be tested, whether if he's saying that Is it agreeing with the Bharat model or it's slightly different? That should be explored. Same thing with his raga Ahimohini and Madhusurja. And in these books, you can find precise statements about the Shrutis used. Most people just don't say anything. They just teach their students, but they don't say it. So Kumar Gandhara goes on record with exactly which Shruti is using on which ragas and so on. So that should be used. I have a recording of Kumar Gandhara at one point, which is his rag Madhusurja, and he is saying that I am doing soft pancham. So he's varying a pancham, which I said achal. And then he says, you think that it cannot be done, right? But I can do it. That's what he says in the recording. So that should be again checked. So the difference is in that Madhusurja rag, he doesn't tune his Tanpura to Shadja and Pancham. He tunes the Tanpura to Shadja and natural Madhyam. So the dissonance which would occur if you do that regular Tanpura tuning is no longer there. So these guys really exactly knew what they were doing. So the exact good tuning actually allows you to do such things like that. So this soft pancham is probably 40/27, and which is the dual of M12. This is my guess. Again, this should be checked by experiment, whether that's the correct guess or not. Whether the Shrutis are points or like an interval spread, that should be guessed. And you can use the lower complexity ratios in these intervals. And how do they compare with actual ratios? This is another experiment which should be done. So I had talked with Satyashil Deshpande, who is like one of the great theoreti and musician, and he learned from Kumar Gandharva. He's the most expert in Tanpura. I with him, Vidyadhar Oak had made a Shruti harmonium, and we checked several ragas, and he sort of explained to me that lots of the things with the Bharat thing doesn't exactly correspond to the way things are used in music now. His son Srijan Deshpande did his PhD on this kind of new experiments. Just like 4 or 5 years ago, he looked at this, analyze the frequency distribution, harmonic distribution in some good voices, and also in Tanpura, and he has his own take on this. So I wanted to mention that. And finally, the last thing I want to say is Western music. And Western music, I don't know much about at all because I never grew up with the Western music. So this is my last slide. But my good friend Noam Alkis, who is a great mathematician as well as an excellent musician and composer and like a chess grandmaster. And I want to show you a couple of pictures of him too, because just so I have talked with him a lot. And this is Noam at Harvard last week. Last week there was a conference at Harvard, and he was just showing me something. And this is Noam Alkis in Tucson in like 25 years ago. This is my son, and he's playing my harmonium. So so we talked about Indian and Western comparison. So for example, this Devil's interval and so on, this was a knowledge I gained from Noam Alkis. Okay, the Pythagorean comma, Didymus comma, and Devil's interval. These are from Western music concepts, and I learned them from Noam Alkis. The difference between Western and Indian music is, in Indian music, Western music, there is no fixed tonic usually. Chords are used more. We don't use same time. Everything is individual, so you don't use two people at the same time or two notes at the same time. So that's the difference. So their requirements are different, but they know about Pythagorean comma, Didymus comma known. They use Shruti frequencies are all there in Western literature also, but they don't use it as a system. There are Shrutis and more frequencies they have studied, but they are not using. So what is typical and what is unique about Indian classical music, and there is no controversy about that, is the 22 Shruti model as used in the ragas. So ragas are not there in Western music, and 22 Shruti model is not also there in Western music. So this is a closed system, very specific to Indian classical music. And so you don't go from 12 to 22. If you use continued fractions, I will just say you go from 12 to 53. And I have run out of time, so I will actually stop here. And I heard that Turkey uses 53 notes. I don't know whether they use equi-tempered or not. But anyway, there is a lot to this theory, and some references. This is the paper I mentioned. The old reference is Bharat. Then Deval, and these people had books. Deval in 1910, Clements in Bhatkhande, which is like a 5-volume work, very standard work on Indian classical music. All these books give you several tables which are inconsistent with the Bharat thing. Some of them are, but Shambhamurti 1954 is the first reference I could find where this table is there. And then Lentz in 1961, Gareth in 2006, and Vidyadhar Oak in 2007 give the same table. But there, as I said, even the new works have some mistakes because in the mathematics, and some people understand the compromises well, some don't understand the compromises well. So that is what I wanted to say. So sorry for going over. So let me stop here and ask for questions.
That's no problem. Thank you so much. That was wonderful. Good job. Actually, I want you to be introduced with Neelam Kothari, that my friend Rohit Parikh just mentioned, that he is related to. So, Dr. Thakur, let me introduce to you Neelam Kothari, who has a PhD from Bombay University in music, and they would like to talk about something too. Neelam ji, are you there? Dr. Kothari, are you there? I think they probably left. But in any case, we will open it for the questions. If you have any questions, go for it now.
If I may just interject here, Neelam Kothari is Rohit Bhai's cousin, Rohit Parikh's cousin.
Yes.
And she was supposed to be, I think she should be able to, she is not able to do video for some reason. But she was supposed to be able to do audio. Anyway,
no problem.
I think that she was very appreciative of, she has a PhD in music, and she was very appreciative of Dr. Thakur's lecture, although she is a music major and not mathematician, so she didn't quite, not in her understanding everything. But she was very appreciative of it.
Very good.
Thank you.
Thank you so much. Dr. Thakur, I have a question. As a layman, somebody who understands that the old music, let's say 60s and 70s, even of Bollywood kind, Lata Mangeshkar and Asha Bhosle, they were singing with help of lot of ragas, and and many of the musicians knew Indian music much better. But well, compare that with the musicians of modern times, and I don't want to pick up too many names, but let's say Ajay Atul. Do you think their basis of music is as strong, and knowledge is as strong? And when they make the music, do you think they make any of these ragas help or not?
Yeah, I mean, it is true that raga-based compositions were much more prevalent than now. And now there is some like fusion or Western influences have come in, instruments have also changed. So our earlier instruments were a lot of, with raga system was a strong presence, but music evolves, and both coexist. So I have no real comment about that, except what your observation is absolutely correct, that things have changed. I mean, raga-based compositions in the Bollywood music has gone down.
Okay.
Once in a while you see beautiful.
Without doubt.
I mean, those days, Ravi Shankar was composing, lots of good musicians were composing, Bade Ghulam Ali Khan was singing in the things, Amir Khan was singing.
D.V. Paluskar.
Bhimsen Joshi was singing for the Bollywood. Those caliber, I mean, but, music occurs in different things. It's a classical music. There are other kinds of music, and, some of there is always a good music and bad music, but I don't want to say many of these things are bad, many of these things are good, and there are experimentations with fusions these days, which has changed. These subtleties are a little bit, once you go on a mass scale, the subtleties are often lost. Maybe that's what I would say.
I see. Well, the old music was on the mass scale as well. Masses were.
No, I mean, if you think about the listeners for a typical Baitak, there will be like 30, 50, because the mass media was also not there, right?
Correct.
But now people like 10,000 people attend one concert. This just didn't happen earlier.
Very true. Okay, well, Amitabh Datta has a question. And by the way, Amitabh Datta is our treasurer of SIA, and he has a question. Go ahead.
Yeah, firstly, I would like to say, Dr. Thakur, thank you very much. It was very informative, though I was sometimes getting a little lost in the ratios, but I managed to learn a lot from your talk. One question I was thinking about is, in my limited idea about music, I've always felt that Indian classical music, there was some parallel to opera in the Western world. So, have you ever thought about or seen some papers written about doing this, the research that you're talking about using opera scales?
There are, I mean, so as I said, I have really not explored the Western literature on these things, except for, one or two books and talking with my friend Alkis. So I am not qualified to say. I don't think, though, they didn't have this Shruti versions. The notes are many times they would use the same notes as this, but the raga and Shrutis are very unique to
Are
Indian classical music.
individual.
Okay.
Okay.
And one thing I would say is I will give you a reference. I'm sorry if I went fast, because sometimes
No, no,
this
no.
table has 22 numbers, right? And it's very
Right,
hard to sort of,
right.
you have to just focus and look at how the explanation is. So maybe the written
Yes, yes.
reference is the best to sort of go through it if you want to go through it slowly. In the talks, I just gave impressions, but
No,
I
no, you did a
explain
super
everything
job.
which I can write down. Yeah. Sorry about that. Yeah.
No, 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 not at all. You did a super job. So I'm very happy with your presentation. Thank you.
All right. Anybody else has any other question?
Yes, I have a question. Actually, I
Please.
had several questions.
Sure.
So if you will be patient. My first question is the obvious one. Namely, that if you see a performance of one of Beethoven's symphonies, right, then there may be 100 people in the orchestra, right?
Mhm.
Having less than 20 would be more or less unusual, right? Now, whereas if I watch a recital of Indian classical music, let's say you might have just sitar and tambura, or you might have sitar, tabla, and tambura, and it's very rare to have fourth instrument. And I suspect that this has something to do with the fact that Indian music has 22 notes versus classical Western music has 12. I'm just talking as a layman, right?
Yes.
But it may well be that even with 22 notes, there may be some compatibility, right? I mean, for example, the tambura is usually played all the time, even when sitar and tabla are playing, and obviously the tambura doesn't play 22 notes. So there must be some kind of harmony. And the question is, to what extent can classical Indian music carry this idea of harmony or even counterpoint?
Okay, so
Which is the limitation.
So as you said, Tanpura only plays two notes, actually three notes, which is the shadja of the current octave, lower octave, and pancham, typically. Sometimes they tune it to madhyam, but pancham. So three notes are constantly played. Their harmonics are present, so you can hear Gandhar and some other notes through a well-tuned Tanpura. And it certainly doesn't produce 22 notes. It produces some of the consonances. But the point is that because of that, there are requirements of which notes sound good are different in Indian classical music and Western music. And Western music doesn't have the sa, so it will also change that, sometimes. But if you see in the orchestra, usually most of the instruments are wind instruments and string instruments, where you don't have to stick to 12 notes. You can vary it artistically. Just like voice can do it, just similarly, the string and wind instruments can do it. The keyboards have limitations. Keyboards are like a set frets. Sitar has limitations, which you can change each time, but you cannot do everything at one time. But so once more, I want to repeat, in a given raga, usually you don't use 22 at all. You use 12 or less.
Yeah.
Even less, right? So in the keyboard, there is limitation because you cannot change the keyboard in the middle of the composition, but you can change you can use only few of these notes each time. In Western music, they do use some variants and they have some kind of notation in Beethoven symphony and so on. As my friend explained, they write in a sort of a different ways of where to emphasize, how to approach things and so on. So the notes are not all sustained. So the timing, how fleetingly, whether you go smoothly from one note to another, whether you accent it, whether you go lower version or upper version, this kind of things do happen. And there are, for example, blue notes, right? I mean, just if you go out of classical music, if you use like jazz and other things, they have different notes which they sound, I mean, they use artistically. So they are not even in Indian music. So blue notes are, so Western music has explored a lot of other notes. The point is they don't have a closed system of 22 or anything. They have an open system of several.
Right.
And that's the difference. So here it's like an all-purpose model of 22 with most of the Samvads consonancies working extremely well and some compromise at M22. That's our model.
Right. So let me clarify my question. Is it possible to have a concert of Indian classical music where there are more than 3 or 4 instruments and they are somehow in harmony, staying within the 22 notes, but still compatible?
It's certainly possible, but nobody does it because Indian music is individualistic. Nobody actually, Indian music is not written, right? Beethoven's score is written.
Yeah.
Indian concert is like one line is written and they sing for half an hour. So unless you just, everybody memorizes and practices 300 times, it's just not going to happen. So the individuals are given more prominence. So they're creative. So that's why, the chorus are usually not classical songs. Chorus is like maybe 20 seconds. They will sort of coordinate things, but usually not more than that. Western music is written in a great detail. And then the composer practices 100 times and then they have a performance.
Right.
In Indian music, they will just go to the concert and okay, and they will just start singing as they feel it. So, there is nothing pre-composed. Every singer, same song, he will sing it differently each time. So coordination is something which Indians don't like too much, I think.
I see. Well, thank you very much. It was
That's well said. Yeah.
Very good.
Yeah, I have a mathematical question.
Yes.
Between this lower sa and upper sa, you multiply by 2, the
That's right.
frequency, right?
Mm-hmm.
So can you put the in between frequencies as 2 to the some power, 2 to the 1 over 12, 2 to the 2 over 12.
That would be the equal tempered, exactly. So 2 to the 1 over 12, 2 to the 2 over 12, that will be 100 cents each. That's exactly what I was saying. But that doesn't sound that good for the ear. That's why this is like 100, is instead of 100, you use 90 and 112. See that?
But is it like getting the continued fractions for?
It is not exactly continued, but continued fractions are used in this theory. So the mathematics uses Fourier series, continued fractions, sine and trigonometric identities, and so on. But as I said, these consonancies are allowing that. And logarithm, these are not exact values, by the way. These the fractions are exact, supposed to be exact. And these are supposed to be the approximations. Because you are taking log, usually there will be a lot of decimal places, which I am just ignoring. Okay. But equal tempered. So piano is supposed to be equal tempered and is supposed to be doing exactly what you said, but it's not exactly either, because 2 to the 1 over 12, do you think that anybody can tune just by listening that well to the 2 to the exact 1 over 12? So it's approximation of 100 cents, which is 2 to the 1 over 12. Okay. So these things are tuned in approximately, and in your nature, your ear, there is always some error tolerance that makes things different also. But this is a theory, and as I said, in theory and practice are the same, but in practice they are different.
Many successive things are Fairy fractions.
No, Fairy fraction, the good approximation, best approximation, and continued fractions do come up in the theory. And that's what I was saying. When I said that you use the lower fraction complexity ratios, like that, then that is basically continued fractions and are used mathematically. But the test is whether it sounds good musically or not, right? And whether it fits with, the ragas depend on samvad or dialogue between the notes. So if you go from one note to another, is there some consonance? Is there some consonance with tanpura? That is what we are looking for. Otherwise, it doesn't sound good to the Indian ear. Indian classically musically trained ear. And the people, I mean, I have seen this Mansoor, Kishore Yamunkar, Gandharva, their perception is at very high level compared to the common people. So common people you can, even slightly badly tuned things won't matter to them. But as you get more refined, your sense, I mean, this exact fractions matter more and more. And now with the technology, you can just create them at will.
That
This is
is
a big
right.
opportunity. So you can do experiments now.
Very true.
Well, when I first came to Harvard,
Mhm.
I heard some classical Western music, and I believe the composer was Gluck, right? And I disliked it so much that I put my fingers in my ears. So I think Indians may have difficulty tolerating Western music because they find it wrong.
Yeah, and probably vice versa too. You need to get that's why I say there is a cultural conditioning, right? Cultural conditioning issues are there. So it might go both the ways, but on the other hand, many people try, and they are both the systems have evolved a lot. And there is a music in them, whether it's your music or whether you connect with it has lots of other issues coming up.
Right.
That's right. Yeah.
So, what's the future of Indian music? I don't think the youngsters are learning it as much as the old guys have learned it. That's just my feeling and
Yeah,
observation. What
I
is
hope
what
it
is
is
your observation?
bright. I hope it is bright. I mean, it's not immediate. I mean, some new talent can come up.
No, but talent is different than the science as a whole.
That's right. I mean, it is true. So there are of course you learn it from your guru, and you have. I
Yeah.
mean, the tradition is sort of looks like dwindling down. But on the other hand, the new generation has lot of availability to listen to a lot of music which is now recorded from the greats. It's very hard to learn like that. You need a teacher. So that is what is going to be a problem. But on the other hand, recordings and availability is more. So there is plus, and the technology, you can play with it more.
Well,
So
one
I
time,
am hopeful. I am hopeful. Who knows what I will happen?
one time, Rahul Deshpande, son of Vasantara Deshpande,
Yeah,
or
grandson.
grandson of Vasantara Deshpande, has commented in a conference that he said that most of the good thing has already been done. We don't know what else we can do as a new. Just repetition of the old good stuff gets us the audience, and they appreciate our version of copying them. And he says, you guys are right. We haven't really produced as much new music which can be
Yeah, that is
everlasting.
true. But that's what I was saying with the mass scale. If you go give concerts on a mass scale, so
Yeah.
let me say this: if you give a concert on a mass scale, many people will sort of try to force you to do something which they already like and just repeat it. But Kumar Gandharva in his concert, somebody gives him farmaish. If somebody says, sing this, he would just tell them, because this would be like a small concert. He said, "Hey, you guys, you want to listen the same thing? Let me show you the new thing." He wouldn't
That's a
listen
good.
to them. These
That's a
guys
good.
like Rahul Deshpande cannot afford to do that with a big crowd, right? They have to please the crowd.
Correct.
So they don't need to do that much. But there are some people who will be creative, much more creative, and that is going to continue.
Good. Very good. Well, that's a good news to know.
I have a question.
Yes,
Yes.
please.
So when you mention all the ratios,
Mhm.
so for example 9/8, which is like 17 by 8 minus 1, or let's say 8 by 5, which is like ratio of two Fibonacci numbers in the sequence, numbers in the Fibonacci sequence. Then you also have 5 by 4. So we in the ratios we see some numbers popping up in Pythagorean sequence, like Pythagorean triples or Fibonacci
So
sequences.
those are
So is it
accidents
just a
basically, and this -1 doesn't have much meaning in this thing.
okay?
So
Okay.
these ratios are occurring the way I said that they are occurring. So the prime factorization does have a meaning, because when you are multiplying and your basic units are showing up. So 2, 3 was the Pythagoras tuning, only twos and threes. And the
Okay.
just tuning, which is the Shruti model, and so there is 2, 3, and 5s come up. Other primes don't come up. So primes do have a meaning, but other things you mentioned are just accidents.
They are the accidents. Okay. Because I know that in Western music, Fibonacci sequence, for example, Bach has used Fibonacci sequence. So that occurs a lot. So I was just
Yeah,
wondering
so
if
there is a difference between, you know, these sequences are used in like progression. I am talking about frequencies of musical notes is a difference than what progression you use in the notes.
right.
So
Makes
in
sense.
there
Okay.
they do use various sequences. That's right. But this is a different topic.
Okay, thanks.
Very
Sir,
good.
one question.
Sure.
We use tempered, we don't use equitempered scale
That's right.
on harmonium when we are performing some classical, some raga or something. Okay, but one thing is that I have heard from many of my other friends who are doing music and they are doing good music, is when it is light music or a Bollywood style or whatever that kind of music is there, non-classical we can say. That time, if we have the tuned scale, not tempered, and some songs are recorded, and if we hear those songs, so in that environment, they appear to be somewhat म्हणजे थोडंसं बेसूर झाल्यासारखं अशा गोष्टी घडतात. That is the experience of some of the studio people who are working and they are good in everything. I mean, classical also they know a lot, and other kind of music forms. They also those forms also they are very good at. So that is the practical difficulty. That's why also they are using the equitempered scale in that environment. Okay, so there are I think there are many environments possible in music.
Absolutely.
Equitempered and non-equitempered tuned harmonium, or tuned harmonium also for two singers. It may not be tuned in the same way, that kind of. Yeah, so I want to hear your opinion in this respect.
No, what you said is absolutely correct. You know, if you use the same, like a keyboard instrument, many times keyboard instruments are used, right? Keyboards have 12 things, and if you change your sa,
yeah,
even if it's tuned, and if you change your
yes,
sa, like a different singer, it will not sound good.
Murchana kind, yeah.
Yeah. And if you use like correct sa, then you have to have tune. Other, if it's not tune, if you just use a standard piano or standard organ or something like that, it won't sound very good to the Indian ear. But you know, the great composers are sensitive to that. I mean, if Lata Mangeshkar sings, they will not use like a piano for a gandhar, right?
Yes.
They will typically use a good sitar or a violin which is tuned or something. So, and nowadays the technology is such that if you are slightly besur, the technology actually just changes your and will correct it. This is an amazing new development. Now that is the software. If you don't tune your software correctly, it will still sound bad, right? Even if it technically supposed to sounds good. So I mean that's another issue. But there is a theory, and you know the consonants. If you are more refined, you certainly can see that. Okay, and Lata Mangeshkar, for example, was considered great because she was always in tune. So you know the instruments, if this doesn't sound good with instruments need to be changed, right?
Yeah.
So she was supposed to have like a Swayambhu Gandhar in her voice. That's what like Dinanath Mangeshkar used to say, and that what basically means that she had a natural ability to have this correct harmonics in her voice, right? So. So some voices are more surreal, and besur is even more. That's besur concept is more like a dissonance. So the partitions are not matching correctly. The frequency is out of tune or close to certain other frequency, but not exact, and that gives you dissonance.
Yeah,
that's
very
right.
good.
So is it that the dissonance is a relative term?
Dissonance is a relative term, but you know, there is never a single note is never dissonant, right?
Yeah.
It's always in relation to other
in
terms.
relation with others.
And what are the others? I mean, it can be just tanpura, like the fixed thing. It can be dissonant to that, right?
Yeah.
So, but it's usually so single note is just a note.
Yeah.
There is no music in it. When you change the note, it's the relations which establish music.
Yeah.
Right.
With that reference, we have to decide.
That's right. Yeah.
Very
And
good.
so if you have a very small difference in frequency, it always sounds dissonant.
Yeah.
All right. Well, we have time for our last question if we are over time, actually. So if anybody has a quick question, go for it. Otherwise, we'll close it. Seeing none, I really want to thank you, Dr. Thakur, to
Well, thanks
explain
very much for
everything
giving
in a
me the
very
opportunity. And if you have any questions, you can send me an email. And
correct.
if you want like a reference, I can send you by email, or it's also on my webpage.
Yeah.
Check it out.
Thank you very
Yeah,
much
so
for
thanks.
doing this. And
Thanks
that's